Welcome. This is Message In, Job Out, where we'll build event-driven workflows in Kubernetes using NATS, CloudEvents, and Project Sveltos. My name is Colin Lacy. I'm a software engineer at Cisco.
My name is Grace Brickley. I am also a software engineer at Cisco.
All right, so who are we and why are we here? So yes, we work at Cisco, as we just said, but we are also the software team for a disco services startup. That disco, it's coming back. And as a disco company, it is not quite popular as it used to be. We have to be cost conscious. And we are a customer-focused company, right? Anyone who is into disco, we want to support them and their interests. And therefore, we are a small team that relies on automation as much as possible. And that's what we're going to talk about, is how we automate things.
Okay. So let's take a quick look at the tools that we'll be using to automate our disco services startup, the first of which is NATS, which we'll use for event streaming. And we'll use CloudEvents for event schema, and Sveltos for event handling. And let's dive a bit more into each of these tools. The first of which is NATS. So NATS is one of the most elegant, lightweight messaging service systems in the CNCF. It is a CNCF incubating project. So that means that it's proven adoption and maturity, but it is still working towards graduating. And at its core, NATS provides communication for distributed services. So it allows your microservices to communicate with one another. Rather than tightly coupling your services with REST requests or gRPC, they're able to just publish and subscribe to topics of data asynchronously. They don't even need to know about each other. They just send whatever message they want to send, and whoever's interested can listen. And NATS can also act as a message bus. So it's often been compared to Kafka and RabbitMQ, but it's faster and more lightweight. So if Kafka is your heavy-duty freight train, think of NATS more like a fleet of race cars. It's faster, it's smaller, and it's incredibly responsive. So NATS provides event storage and consumer tracking. When it was initially created, it actually was purely in memory and fire and forget. But with the introduction of Jetstream, that provides event storage and consumer tracking. And it also supports authentication and authorization policies for both producers and consumers. So you're able to actually control who can publish, who can subscribe, and even what subjects they have access to. And lastly, it does not care what your message payload looks like at all. You can send any arbitrary data, whether that's a simple string, a JSON, or even a blob. So what does that look like in practice? So we have our NAT server that is configured to save any message that it receives on disk storage, and that's our stream. And then we have our clients, which pipe data into that stream. They connect to NATS via service, and we don't want that data to live in that stream forever. We want to be able to access that data, and that's where the consumers come in. So consumers allow us to access the data that's living on the stream, and they actually kind of act as a filter. So we can configure our consumers to access a subset of that data and then feed that into whatever service it might be tied to. And you can also have more than one consumer on the same subject and more than one service tied to one consumer. And so we can follow many of the standard event-driven architecture patterns, including fan-in, fan-out, and Saga. And so that's just NATS. Let's move on to CloudEvents. So CloudEvents is a CNCF graduated project, which means that it is production grade and it is widely adopted within the ecosystem. And it is a specification for describing event data. So it provides a common schema, whether your event came from AWS, GCP, or even your own local service. It provides a common way to parse these events. And it gives syntactic meaning for each key value pair. And this consistency makes it easier for your downstream consumers to process each event without having to have any custom parsing logic. CloudEvents also provides SDKs for most major languages for ensuring spec compliance. And it's extensible with standard optional fields. So you're able to input your own fields without compromising interoperability. And lastly, CloudEvents are transport agnostic. So you can encode them in multiple formats, including JSON, and you can send them over HTTP, Kafka, NATS. Think of it as like the lingua franca of Cloud Event data. So it's just a way to ensure that all of your systems are speaking the same language. And this right here is an example of what a Cloud Event might look like. These first 4 fields, spec version, type, source, and ID, are the required fields. So you can actually send a Cloud Event without any data, just with these fields. But then we have our standard extensions like subject, time, data content type, and data, where you can send whatever information you need to send in whatever format you need to send it.
All right, and then we'll get into Project Sveltos, the third tool in our stack. All right, so it is open source software. All right, and what that does, Project Sveltos acts as a management plane for Kubernetes resources across multiple clusters. So it can actually manage a fleet of clusters. We'll only be working with one today, but from what the maintainers have told me, I think in production, we've seen a maximum of 127 clusters managed by a single Sveltos installation. Right, so usually run from a management cluster, but you can install it directly into the cluster you want to manage if you want. Right? And what that does, the way that it works in managing resources is when you have a managed cluster registered with Sveltos, you apply labels to it. Right? And then it matches profiles to labels for composability of the things you would like to set up or install or deploy in your Kubernetes cluster. Okay? On top of that, it has a built-in event framework for reactive provisioning, and that's how we're going to get into event-driven architecture today. And part of that event framework, if you so choose, and we'll look at a diagram in a second, is it integrates with NATS directly, right, and listens for events that match the CloudEvents spec. So, diagram. Right? Let's say we have a management cluster and an application cluster. Right? Sveltos is running in our management cluster, and that's obviously us, right? So as we work with Sveltos, we're going to maybe upload one of the Sveltos custom resources called a cluster profile, right? What that'll do is it will tell clusters that match that profile, hey, deploy out some resources, maybe a namespace and a service account, right? So that's one option of how we can manage our managed clusters, right? Another is we might stand up some custom resources called event source and event trigger. We're actually going to look at those in a second, right? In that case, Sveltos is actually listening to the managed cluster control plane for events that are happening, okay? And when that happens, it will respond and say, install some resources. Maybe create a role and a role binding, all right? But the third option here, let's say we have a NATS cluster, a NATS server running in one of our clusters. It could be the same cluster that the resources are destined for. It could be any one of our managed clusters. So we'll upload a configuration to Sveltos and say, listen to this NATS server, right? Listen for events. And when NATS raises an event, Sveltos will push information to the control plane and stand up more resources. And it could be any type of resource, right? Any type of Kubernetes resource, any type of valid API from other add-ons that you've installed in your cluster, could be anything. So now for everyone's favorite part, the reason we're all here, let's see that groovy YAML, right? So let's see, we're over here now. Cool. All right. Oh, wait a minute. I skipped a slide. Let me go back. There we go. We're going to look at 4 resource types before we actually get to looking at the YAML. All right, so the first we're going to look at is a secret, right? Sveltos connects to the NATS server using a specifically named secret called Sveltos NATS. Okay, we're going to look at the configuration for that, and we'll show you how it's working for this demo. The next is the event source, right? It's Sveltos custom resource, right? And that's going to tell Sveltos, listen to NATS on this stream with these subjects. Cool. Then the event trigger, how Sveltos will respond when an event comes from the event source. And then finally, a config map, right? That's going to hold the YAML for each resource that needs to be applied. All right. Here we go. So this is obviously JSON. And this is what goes into the secret that's configuring Sveltos to listen to NATs, right? So we have the URL it's configured on, the name of the NATs stream, right? So that's the durable data store that events are piping into. And here are all the different subjects that it's going to subscribe to. And then as far as authentication, right, we've got our username and password that NATs will use to authenticate with the NAT server, okay? This is an event source, right? This is that custom resource that's part of Sveltos. So we're saying, listen to the customer registered subject, right? And here's our cloud event source and our cloud event type. So this is really all you need, right? It's not a lot of YAML to tell Sveltos, listen to this subject on NATs, right? And start to prepare a response. Well, how do we trigger that response with an event trigger? Okay, so this is the corresponding event trigger to that event source. It's listening to the customer registered event source right here, right? And what it's going to do is it's going to reference the data in this config map and say whatever is in there, deploy that out. Cool. What does the config map look like? It looks like this. This is a config map, right? And so as far as the data in this config map goes, you can see this is the YAML that's going to be applied. Right? It's a multi-line string from a config map point of view, but as far as Sveltos is concerned, this is what it's actually going to send to the control plane of the managed cluster. A couple things going on here. What does this look like? That's a Golang template, right? So you have Golang templating built right into the interpretation of this YAML. And down here, these are Sprig functions. So Sprig is built into Sveltos, so you can actually manipulate this data as it's coming through. It's pulling data right from the cloud event and injecting it into these environment variables that are going to stand up our resource. Okay, so you can use the event data to manipulate the resources that are deployed. Okay, how crazy can we get with this? Well, in this one, right, I'm actually iterating over a list, and I'm creating a job for each user that comes in over this cloud event. All right, so you can use everything that's available in typical Golang templates within this resource definition. But not just, do we have the, yep, okay. So let's go back.
Okay, so what about the jobs? What about the actual units of work in this workflow? There are 3 steps that comprise each job, and the first of which is pretty simple. It just spins up a container, and it reads the environment variables and gets all of the context that it needs from the event that triggered it, including whatever payload was sent over the cloud event, or via the cloud event. And then the next step is it just does the work. Whatever its singular responsibility is, whether that's create a database entry or send an email like you'll see in this demo, or something else, it just does that work. And because it's a Kubernetes job, it has built-in retries, it has logs to standard output, and it is predictable behavior. It's like, yeah. And the last step of this workflow is it just raises an event that follows the cloud event spec, and it publishes that back to NATs. So why use jobs as our event handlers? They're easy to test, to scaffold, to document, and to debug. So what exactly is it that we're automating? We've had a problem running our Disco services startup. All of our customer onboarding has been manual, which has been super error-prone and time-consuming. There are only 2 of us, so we need to focus our resources on doing other things. And it also leaves our account managers left in the dark. I forgot about the account managers. They're also account managers. So they don't know when we have a new customer that they need to reach out to. We're a small team, so we're going to rely on automation to solve this problem for us. And as you can imagine, the Disco services industry is really small, so customer satisfaction is extremely important to us. We rely on word of mouth to get new customers, and so we need our customers satisfied and to be able to refer us. So let's take a look at what the customer onboarding automation is actually going to look like. When a new subscription purchase is made, we want to automatically create a new corporate customer account in our database. And from there, we want to create new user entries. Number one for the account owner in the middle, and two new user accounts for the account admins at the top and the bottom. And after those user entries have been created in the database, we want to actually send them a welcome email. And the workflow is not done for the account owner. After they've been sent the welcome email, we want to create a new customer outreach record in our sales and marketing team's database. And then we want to notify our sales and marketing team that they have a new account owner that they actually need to reach out to, so they're no longer left in the dark.
All right, so let's talk about some NFRs, right? Non-functional requirements. So first, we don't make a lot of money. We are in Disco. So we want to save on compute costs as much as possible, right? The solution has to be able to scale for bulk onboarding, right? If you go to somewhere like a roller rink, you're going to find other Disco fans, and you want to get them all at once while they're right in front of you. It has to be extensible for organic growth, right? And on top of that, we need to be able to embed logic into our workflow steps, and we've seen examples of that so far. Finally, built-in retry for each step in the workflow. We don't want the workflow to just fail if one of the steps collapses, right? We want retries built in. So the way that we're solving this, right, we've got Sveltos, and we've got our managed cluster that's running NATS. So we upload that configuration secret to our management cluster, right? And that's going to tell Sveltos, connect to NATS, start listening. Cool. And then we upload the event source, event trigger, and config map, so that when NATS sends a cloud event message over to Sveltos, Sveltos says, I know what to do with this. It's going to stand up a job in that managed application cluster. And then that job is going to run. It's going to raise an event to NATS. And if this looks like a cycle, it's because it is, right? After every job runs, it raises a new event. That triggers Sveltos to kick off a new job, right? And this pushes through our workflow until the workflow is done. So, it's demo time. And now, I'm sure you've all experienced the spotty Wi-Fi, right? So there was a bit of a panic and a run back to the hotel to record the demo on reliable Wi-Fi. But here we go. All right, so let's kick it off. Get your roller skates. It's demo time. So we'll play. All right, so I've got a script that's going to create this payload. It's going to send it off and publish it to NATS right there. If we look at our database, currently, we have no, wait for it, we have no customers, Disco. If we look at our users, also no users, okay? I've got MailHog deployed in my application cluster. It's got no emails. And our jobs list, no jobs fired off yet. So here we go. I'm going to run this script to publish an event to NATS. All right, there it is. That's the event that was published. And we'll come back into Lens, and we'll start waiting for these jobs to come in. And they're going to start coming in. First one, there it is, create customer. So we create the customer resource in our database. Right? Now that just completed. Cool, so it raised an event to NATS. Sveltos is catching that event. And what's it going to do? It's going to take all of the users, it's going to iterate through that list of 3 users, right, and create a new job for each one. And as each one of those individually completes, we'll start to see the welcome emails come in, right? Now, each one of those is a job sending a welcome email to our users. Once those 3 complete, one of them, once the account owner has been emailed, right, now we'll create the touch points of the database. And finally, any second now, we'll notify marketing. There it is. Okay, so marketing's been notified. And this wasn't demoware, right? This is actually entering data into the database. So come back into corporate or users, right? Refresh it, and now we've got 3 users in the database. Go to corporate customers, and there's our corporate customer. And our touch points, there's our touch points record. Come back over to MailHog, refresh, and there are 4 emails, 3 welcome emails and a marketing notification, right? So the full workflow, right, fully automated, using jobs for retry, met all of our NFRs. Cool. So just to wrap this up, all right, what we liked about this was the organic growth. There's no master DAG to manage before you wire in new steps. All you have to do, right, is if you want to extend this, is add a new event source, a new event trigger, and a new config map containing the resources you want to deploy. That's it. You can use the existing events that are already there and tack on fan-out steps, or just keep the event flow going with more steps and more downstream. It also maximizes automation in low resource and edge environments. It's using Kubernetes to manage your step deployment, right, your job deployment. So what happens if you're low on resources and you queue up a job? It'll just stay in pending state until resources are available, right? So that's all being handled by the Kubernetes server. We don't have to worry about that. It works across multiple clusters. Like I said, you can use Sveltos to manage hundreds of clusters. We did this all in one cluster, but if we wanted to, let's say, create a new customer cluster using the cluster API, we could have done that, right? If we wanted to create a namespace for tenant isolation, every time we create a new customer record, we can do that. And that's one of the most powerful things about this, right? It doesn't just work at the data plane, it also works at the control plane. It crosses the streams, right? Last thing I want to point out, all of these projects are open source, okay? They all have multiple repos in each project that require management and maintenance. Right? Each project has a good first issue label, and all of them have a documented contribution guide as well as a community Slack. So please consider contributing, help support open source software. All right? And that's it. If you'd like to learn, if you'd like to learn more about Sveltos, the project maintainer, Gianluca Mardente, is here, and he's going to be hanging around afterwards, and we will also be here for questions.